Okay, are we streaming? Sound. Can you hear me? Can you hear me? Is this working? I'll give you a few seconds. Um, ooh. Hey, good morning, everyone. Albert, Fatem, Salvador, Arasto, Rodolfo. Hey, all right. Good morning. How are you doing? Hey. Okay, another week comes in. Mm, it's decaf. Remember? Decaf. Hi, Chandra. How are you doing? Okay. Hey, Andres. What's up? All right. So, um, what do we got for today? Whew, what a week. Um, remember I was telling you last week that I was super busy this month? Well, it's only getting worse. But it's all for good. It's all for good. Lots of good stuff. Lots of opportunities. Lots of nice projects going on. I mean, the world is a little turbulent right now. There are many things that are happening that should not be happening, and we should be making a better job as a modern society to improve them. But um, at a personal level, I'm doing fine. I'm doing fine. I'm actually doing a lot of really interesting things and really cool stuff. Hey, Rami, how are you doing, man? Good to see you. Wait. There you go. Um, I don't know if you know him. Rami, he just said hi in the chat. Rami Idaros. He's been super helpful in helping me with all the videos and all the editing and like taking the live streams and then like chopping it and making it a video that is easier to digest and that it has all the blah, 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 that it cuts them out. He actually wrote a Python script to make that happen. I think you should tell us about your work at some point and share it with us. That would be really cool. Uh, all right. Nightik, 1241243. What is that leaking? I don't know. I'm not sure what you're referring to. Ipsita, how you doing? Ahmad, yes. Discord channel, of course. Um, where is it? Oh, it's here. Oh, Discord. Wait. So let me share a link. Actually, the Discord channel was very helpful this week because I've been super busy. I didn't really know what to do for I'm working. So let me get the link first. Okay, so I'm gonna put it here. Um, I know, Arasto, Python. What are we gonna do? Python deserves some credit also. You know how I like joking about me not liking Python? But it's just a joke. It's actually a very good programming language and a lot very popular. And it's the default if you want to do machine learning. So you can do nice things. Hey, Hari Prasad, how are you doing? Okay, so I just posted the Discord, a link to the Discord channel, and I can see that there's already people joining the club. The Discord channel, the server was actually very helpful this week to let me decide what to do because I was telling you I'm really busy this month, so I don't really have time to prepare ahead of the streams. And I was working on this introduction to parametric design series, basically like let's learn Grasshopper and the fundamentals of some geometry, etc. And I want to do a really good job at that playlist. So I started doing that, but I put a pause on that one because I really need to concentrate and make that well, and I don't have the bandwidth, the mental bandwidth these days. So I'm putting a pause on that one, and I will resume probably at some point in July. We will start doing like double streams again, which we're not. So today is going to be just a single stream this morning. And for today, I wanted something a bit simpler, a bit more something that didn't require so much preparation on my end. And in general, I'm also trying to do, I want to keep switching before things that are a bit more beginner level and more advanced level. But I think I wanna focus a little bit more on beginner side of stuff these days, just because I want to build a foundation of techniques and repositories and like simple things that we can learn together, so that when we go into the more advanced stuff, I can always point back to like, oh, we have a gem where we talked about how to calculate this thing, or I did a piece where I described this particular process, and then we can use that process to do more complex things. So I think for the time being, you can expect me to start building more like simple units of knowledge, of design, of computation, of geometry. Um, I will be probably doing back and forth. I will be doing more like perhaps more complex algorithmic modeling challenge or something like that. But I want to build a good foundation for the time being, and then once we have that foundation together, we can start doing more complex stuff. Um, and yes, Arasto, I think at some point I will do some Python. Probably I will probably do an intro to Python in general, and then I will move on. I will focus on using Python in common computational design frameworks that I think are interesting. So, for example, Python scripting in Grasshopper could be a good one. Python scripting in Touch Designer, that would be great. Touch Designer is really cool. I have a good friend who's using it a lot for when we DJ. He does the visuals, and he uses it's really really cool. So it will hopefully happen at some point. Probably not very soon, but sometime in the future. Okay. So what I want to do today is, I think we're going to do a geometry jam, and it's going to be a simple one. It's going to be we're going to write some algorithms for point sorting. So remember last week? Remember last week when we had a point cloud, right? And then we wrote this thing to simplify the point cloud and remove duplicates or remove points that were very close to each other. So this could be like a second step. We're like, okay, now we have a clean point cloud. So can we write algorithms that, instead of having these points ordered randomly, they follow some order? So for example, they're ordered based on their x coordinate, based on their y coordinate, their z coordinate, or maybe we can sort them based on proximity, so that if we use them to create a polyline, instead of being a polyline that was just like zigzagging around, like was a polyline that was connecting points that were closer to each other, and then the result is going to be visually like a polyline that is like, it's going to be cool. So yeah. So, oh, actually, hey, Flor. So actually, I was on a review recently with Carlos Trito, together here at Harvard, and he's a really nice guy. I like him a lot, and it's true. He's got a lot of good stuff online. So go ahead and check it. Can you post some links if you don't mind, Flor van de Velde? Um, Nighting Dr. Vector. Yep, that's my DJ name. You're right. Okay, another thing. How are you guys? So it's really hot today here in Boston. I'm gonna turn the AC. Um, can you hear it? Yeah, it's bad, right? Um, there's a lot of background noise, right? Can you hear the AC, the air conditioning? Yeah. Hmm. Uh, I don't know what to do about that. I think it's still tolerable. Maybe I'm just gonna turn it off, and if I start sweating, then I'm gonna turn it off. I'm very picky with noise and with good sound quality. My friend Nono just ruined just ruined me when it comes to sound quality. So now I wanna live up to the expectations. So I'm gonna turn it off, and if I start sweating and it becomes real bad, then whatever. I don't want to pass. I don't want to pass out while doing the live stream. Imagine like and then the live stream just keeps going. and you guys have to call someone to come rescue me and take me to the hospital. Hey Benson, what's up? Okay, Sujai, welcome. All right, so another thing. Um, um, Remember, so there will be no live stream next week because I remember from last week I will be teaching a seminar along with my friends Nono and Nate at the Digital Futures World Conference. So this is a conference that was organized by Neil Leach and um, Philip Juan, I believe, were the main leaders in the organization from Tongji University in China. And it's I spoke about this last week, but it's like a massive event. It's like a full online, full week, 24/7, three time zones, workshops overlap with each other. I think it's an amazing initiative. I think they got something like 10,000 applications. It's completely free. Um, I don't know. I agree. It's great. So they invited me to participate, and I was very happy to organize something. So I'm organizing a 1 day seminar that's going to happen next week on Saturday. What is it? Saturday, June 27th, and it will be going on from 9 a.m. Boston time to 5 p.m. Boston time. And it's just going to be like a series of lectures, talks, conversations, Q&A, mainly led by Nono, by Nate, and myself. We're going to be talking. Oh, let me show. There's a link here somewhere. Um, North and South Americas, and then this is us. So the seminar is called Machine Intelligence in Architecture, and we're going to be discussing the role of machine learning and artificial intelligence in design and in architecture. And it's going to be a non-technical workshop. We're not going to write code. We're not going to show you nothing. It's going to be more a high-level overview of where we are in terms of machine learning and artificial intelligence these days, and specifically in the field of architecture. So what's out there, what are people doing, what kind of things are accessible now, right now, what's the research that is cutting edge these days. We're just going to give like an overall overview. We're going to show some of our personal work, some of the tools that we have made available for the community out there. We still have to decide whether if we are inviting some guest speakers as well. But yeah, so we're going to do that this coming Saturday, June what? Sorry, I said June 27th, 2020. If you're watching this video from the future, I'm sorry you missed it. But yeah, so the date is here. Yes, the registration is closed. But we don't have a cap because we don't have a cap on participants. We're just going to be streaming openly, and it's going to be probably like some kind of Zoom call or Zoom webinar or something like that. So if you want to join, I don't think you can register officially anymore, but just shoot me an email or write on, or maybe I'll post on the Discord channel. I'll post a link if you just guys want to join. It's totally up to you. I think we have a 300 people limit just because Zoom cannot take more than 300 people on a call, or you have to pay super premium for that. I'm not sure about that, but if anyway, if you really, really, really want to, just get in touch with me on Discord or go to the bonfire section, and then probably I can post a link to something there. All right. All right. Mahila, is there going to be any interaction with the students? So it's mostly going to be lectures, but hopefully, so it's mostly going to be us talking, us showing stuff. But after every lecture and after every main session, so we have some schedule here, something like lecture by Jose Luis, lecture by no, lecture by I don't know. So, but after each one of the lectures, we hope to do some Q&A. What that Q&A will be a mix of just like answering questions that are on the chat and we will open it up at the end of the seminar to a larger, oh, you can't see this, sorry. We will open it up at the end of the seminar to a larger conversation between everyone. Whether if we make, what we do is like we switch to a normal call and everybody can turn on their video and have a conversation, or if it's 300 people, maybe that's too much. Um, I'm not sure. We don't know yet. We have 300 people enrolled. So we're still talking about how to make this happen. But we do want to have interaction with students and with the participants. We're just not clear yet how that's going to look like, but we want to make that happen. So we're going to find a way somehow. I would actually be super happy to have like a Zoom call with 300 people. I kind of 300 people in the world who are interested in machine learning and architecture. I think those people deserve a screenshot. So yes, so we are going to try to make that happen, whatever that looks like. I'm not sure about whether if we will record the sessions, because we also don't know what kind of Zoom do we have, if we can record for 8 hours, the quality issues, blah, blah, blah. So if you really, really don't want to miss it, I recommend you come, because I'm not sure about recording, okay? Okay, so, my phone is telling me that we're live. Okay, because I have notifications activated on my channel, right? Duh. Okay, so, okay, and it's very hot. But I can still take it. I'm from southern Spain. I can take a lot of heat. All right. Will you take a look at WebEx2? It's pretty nice. Can you have a 300 people 8-hour webinar on WebEx for free? Is that possible? Do you think so, Arasto? Because I do have a premium Zoom account from Harvard, so that gives us like more space and to work. And we also have the organization has provided a business account, a Zoom business account for organizing the workshop. So we have to look into that. Okay, but I think we're ready, right? Should we get started? Let's get started. So so bottom line, no live stream next week. We're going to be doing this, and if you want to stay, I will post updates on what is this looking like. I will post them on the Discord channel sometime soon. Okay. Benson, I don't want to oversell it. It would be a cross desert to join. I would cross a desert to join machine learning webinar. Well, actually, another thing that we tried to do, we also wanted to do a 1-day seminar for all of those who may want to join other, because like if you look at the website, there's like a ton of really interesting workshops, and there are so many that most of them overlap. So what we tried to do was to just do, okay, we're going to take Saturday, we're going to take the first day. We're just going to do like a super high level, non-technical introduction just for people who just want to get a sense of what machine learning looks like and what kind of things you can do. And if after that you are really interested in spending more time and learning more and getting into the technicals, then just sign up to any other. There's a lot of other AI in architecture workshops like Matias Del Campo, Daniel Bolojan, Gouben Chazelle, Diego Pinochet. He's going to mix that. He's going to mix his workshop with some robotics as well. I think I'm having drinks with him tonight, so I can tell you perhaps later on. So our intention was, if you are interested in what we show you, then perhaps you can move on and join somebody else's AI workshop where you can learn more and the technicals and actually get your hands dirty doing stuff. All right. Also, unfortunately, neither Nono, Nate, and I have time to do like a full 9 days technical workshop. So that's why we chose to just do like a simple seminar, an introductory thing, first day on Saturday. Mm-hmm. Okay, so let me get set up. So um, we're gonna do point sorting algorithms today, and for that, what are we going to do? I'm going to start with the point cloud that we did last week. Where is that? I'm going to start with yes. So this file, the clean duplicates. Um, so yeah. So let's say here we have all these points, right? Uh, we have a point cloud of 1,000 points. Okay, and then let's say we want to sort. Well, sorry. Any questions before? Before I don't want to. But I did have a great session with Professor Ikeda on it. With the student, it was great. We were about 40 and 50. Yeah, Professor Ikeda is really cool. All right. So, what was I saying? Yes. So point sorting algorithms. So we're going to start with the point cloud, and we're going to write some algorithms to take this point cloud and then sort it. For example, we're going to start by sorting them by x coordinate, then we're going to optionally do either y coordinate or z coordinate. Then I think we could probably do something where we switch and we say like, well, we can do x coordinate from top to bottom or vice versa. We could do that too. We can add that as an extra feature. And then I would like to order them by distance. So the ones that are closer to each other, because that's going to create like a very nice, it's going to create like very interesting like thing that's going to start like curving inside out. It's going to be kind of cool. So let me save this file before I mess up the original one. Let me save up. Where are we? What is it today? The 20th, right? Okay. And that's going to be point sorting. Yes. Okay. So we're good. And I'm going to turn up Dropbox because otherwise my computer is going to start flying away. I bought this laptop. I'm not going to say the brand, but I'm not very happy with it. And it was a very expensive one because I really needed power. It's powerful, but it's not. I'm so much happier with my previous laptop, and it's quite beautiful though. Like design-wise, it's gorgeous, and it's got a lot of really good specs. But it's just not. There's a bunch of things that I'm not happy about. Anyway, so where are we going to start? We're going to start here, and I'm going to say like we have a point cloud, and so which is the last geometry gem we made? Number 5, right? So number 5 was the one where we were cleaning up this file, right? Let me look that up. Yes. Geometry gem 5, clean duplicate points. All right, so I'm going to point to that. I'm going to point to that, and then I'm going to start writing. I'm going to start a C# component, and then I probably want to do some whiteboarding. I'm going to do some whiteboarding to explain the algorithm, and then we will go and implement it. Benson, no, I bought a Dell once. I did buy a Dell once. It was not a great machine either. No, I was not very happy with that. I still have it actually. I gave it to my nephew. He plays Minecraft on it right now. Actually, well, you know what? It's not a bad machine because I bought it. I guess I bought it 8 years ago, and it's still useful for playing Minecraft. So it's not such a bad machine actually. Um, anyway, sorry, I'm derailing. You guys are distracting me. Oh. I'm joking. I'm actually very happy about the possibility of being able to do this while having some kind of human interaction. So, all right, where were we? Yes. All right, let's start recording then. Okay, so let's get started. I'm gonna start with some code that I wrote already for the previous geometry gem that I did, geometry gem number 5, where we wrote an algorithm to take a point cloud and then to clean up the duplicate points or to clean it up from points that were very close to each other. Okay, so if you remember from that gem, I wrote this simple Grasshopper script. So Grasshopper is a visual programming environment that you can use to generate geometry procedurally. And then what this script does is it generates a set of 1,000 random points. I can increment this or make it slower or make it lower, but we can increment, we could just create a 1,000 random points inside of a cube that is 2 by 2 by 2 side. Okay, if you're interested in learning how I made this, just go back to that video, which will probably be on the description or popping up somewhere here, and then just check this out. But if you don't have this, or what you have is a CSV file where you have like a million of points or whatever, then just like whatever code you have that you can write to make these points accessible as a sorted list, that's the point that where we want to start. So here I have a component that just has, if I drop a list here, it just has a ordered list of XYZ coordinates for each one of those points, and these coordinates are wrapped into a point class. So whether if you have a point class on whatever system you're using or not, it's up to you, but it's a very simple thing that you can do, and it's very easy to make to them manipulate them. Okay, so I'm going to start from this point. I'm going to assume that you have a list of however many points that form a cloud. Here I have a visual representation of where they are. And the point of what we're going to do today is that if I were to, for example, write an algorithm to create a polyline between these points, this polyline will be basically a mess, just because these points are in any random order, whichever order they were generated, because we generated them randomly. There's no order and there's no structure, so it just looks like a yarn of points, whatever. So what we want to do is we want to take these points and sort them by a particular logic, so that we could, for example, afterwards create a polyline that had like a different visual flavor because the points are ordered in three-dimensional space. In this video, I think what we're going to do is we're going to order them by X, Y, or Z coordinate. So like sweeping them in one Euclidean direction. And I think we're also going to sort them by proximity. So we're going to grab one random point, the first one on the list, and then we're going to start ordering them by whichever other point in the point cloud is closest to that previous point. And therefore that will create a polyline that will start joining points that are very close to each other and give it like a very different flavor. All right. So what I'm going to do is I'm going to, because I'm here, I'm writing this in Grasshopper. I'm going to create a Grasshopper C-sharp scripting component so that I can write custom C-sharp code inside of it. So here I'm going to rename this input to points. I'm going to remove this other input. I'm going to make sure that this input is of the type point3D so that objects are correctly casted into the object. And then here, the output, I'm going to call it sorted points. All right, and that one I don't need to cast. I'm going to turn this polyline off, and then once I'm ready, then I can just double click on my component and start writing C-sharp code inside of here. If you're writing this in some other C-sharp environment, the translation is going to be super immediate because I'm not going to be using any of the Rhino common methods. Or if you're writing this in a different language like Python, JavaScript, whatever, then all the technologies and all the methods that I'm going to be using are going to be very easy to translate to that other language. Okay, but as usual, before we start writing any code, the first thing that we need to do is we need to think with our heads about what we're going to do, and some planning and some sketching is probably going to be in order. So let me draw a couple of diagrams and explain how we're going to tackle this algorithm. The first one being ordering them, for example, by their x coordinates from the smaller one to the larger one. Okay, so let's get to the whiteboard. Good. Okay, so whiteboard time. So, where is the whiteboard? The whiteboard is here. Ah, where is this? No, the whiteboard should be here. Exactly. Okay, and I have my drawing thingy. Okay. So let me draw some. Let me draw a list. Okay. So, oh, what is the color palette? I keep saying that I'm going to. I keep saying that I'm going to. No, it's not that bright. I keep saying that I'm going to learn some sketchbook, and I never do. So you should call me out on that one. What is it? What is the lagoon? Okay. All right. So I'm going to choose black here, and I'm going to do lines because, yeah, I'm not liking when I draw those squiggy lines. Okay. So let's say we have line, 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 line. This looks so much better than when I make this crappy, right? And so for the points are going to be, well, I don't want this anymore. So it's going to be 0, 1, 2, 3, 4, 5, 6, 7. And I'm going to do, yeah, well, 10 points. Pop and pop. I should have. Can I? Okay, can I take all of this, cut it, and then paste it into a new layer? Look, I'm learning. Okay, that's great. And how can I delete this layer? Layer. Okay. All right. Nope. No. 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 And I'm going to save this, and I'm going to create a new layer here. Okay. And what am I going to do? So what do I want to explain? I want to explain that I want to start by taking each one of these points have an XYZ coordinate, but we're only looking at the X coordinate. Should I write X coordinates? Let me write X coordinates. So for example, let's say that this is going to be 1.5, 2.4. Oh my god, this is terrible. Let me try again. 1.5, 2.4, 3.7, 0.6, minus 1.3, minus 2.7, 1.5, 2.3, 2.2, and 0.5, for example. I don't know. It doesn't really matter. And I'm going to call this this is going to be, no. This is going to be, sorry. This is going to be, oops. This is going to be the X property. This is going to be the X property. And this is going to be the index number. Okay. And I'm going to turn this on and off so that I can start talking about it. Oh, Benson. Oh, did I recommend that book? Code: The Hidden Language of Computer. Oh, I think I recommended that book on my Harvard playlist, right? That book is really good. It's really good. Okay, so, and then what I'm going to explain is we need to check, and then we need to move these things to a new list. We need to move these points to a new list. That new list, I can probably start writing it as I explain the concept. Yeah. As I explain the concept, which I'm going to explain by saying that we're going to find a threshold. We're going to set a threshold. We're going to find which point has a lower has a lower threshold, and then when we're done, we take that point, we put it into a new list, and then we remove it from this list, and then we start over and over again. Okay. Alrighty. I think we might be ready to start, I guess. Yes, I think we're ready to start. Okay, so we're here, yes, and this is, and I'm going to shut this down. I'm going to close Discord as well, in case somebody texts while, so that I get a notification while, okay. And where am I? Which color am I? Here. Green. Okay. I'm gonna take red. I think I like it better. It's more like the brand, the channel brand. Okay, let's do this. So in order to explain this, let us imagine that we have a list of unsorted points, okay? And I'm going to represent that list, which these amazingly designed lines that I've done here. At least this time they're not squiggly lines. They're like perfect straight lines. I'm getting much better at this, right? And so each one of these lines represent a point in three-dimensional space, and each one of them has whatever location. So and also because it's an ordered list, remember that each one of these points within our list has an index number. So if I go back to Grasshopper, we can see here visually that each one of the points has 0, 1, 2, 3, 4. This is the index number. It always starts at 0, and it's always correlative by 1 unit. Okay, and but if you had this on a non-visual environment, it's fine. You still can use those numbers to point to these particular points. And each one of these points is going to have 3 properties, x, y, and z coordinates. And because we're going to start, for example, sorting them by the x coordinate, we don't really care about the other ones. So each one of these points is going to have, for example, an x coordinate with whichever value. I just wrote some random numbers there, and because they're random points, they don't follow any order, as opposed to the index number, which is always order. Okay, so here in this list, each one of these points have an whatever random x value, and our purpose is to write an algorithm that is going to take all these points and create a new list where all these points are sorted from 0 to 9 by their x coordinate, from the smaller one to the larger one. So what we're going to do is we're going to write an algorithm that is going to start going over this list one time per each one of these points. Is going to find, for every time we loop over this list, is going to find the point that has the smallest x coordinate at any given time, and then it's going to move that point to a new list. And then, because as we're moving them, and as they get added to the new list, they're going to get added by whichever is smaller. Okay? So, how is that going to happen? Well, it's going to be super easy. What we're going to do is, first, here we're going to do a first pass over the whole list, and we're going to find which one is the one that has the lowest x value. And the way we do that is going to be super simple. We're going to start with, I'm going to create a variable while doing my algorithm that I'm going to call something like, for example, current minimum x. Okay? And what I want to do is I want to use that variable to check, when I'm checking each point, to check which one is the lowest x value that I have found while going through any of these points. So for example, imagine that I start this current minimum x with a really large number. So for example, like 1 million. All right? I'm going to start with 1 million. And then what I'm going to do is I'm going to write an algorithm that starts with the first point of that list. And it looks at the x-coordinate. And it says, is the x-coordinate this one? Is it smaller than my current minimum? And if that condition is true, then what I'm going to do is if that's true, then I'm going to replace the current minimum that I had, which was a really large number, with the last value that I found, 1.5. And as I do that, I'm also going to keep track of where I found that point. So I'm going to create another variable that I'm going to call, for example, current I. And I'm going to turn that into 0. That is not great. Let me redraw this. Okay, let me redraw this because that's going to get very messy very soon. All right, and then I'm going to create a new layer, and then can I write text here? Yes. So I'm going to okay. I'm going to use the corporate typeface. Current minimum x. And actually, now I'm going to use something like consolas or something that is a bit more. Yes. So, oops. Oh my. How do I rename layer, edit text layer? Okay, so let me do much smaller. And can I? So how can I move this? Oh no. Okay. Okay. Current minimum x, and okay, and I'm going to edit the layer. It's going to be equal to something. All right, and then I'm going to create another one, which is going to be current index. And I'm going to move that one. Is this moving? No. This is moving. Okay, and I'm going to create. Okay, let me redo the previous one. Delete layer. I can't believe how. Current minimum x. Oh, my current minimum x. Okay, and then let's move this here. All right. Okay, so I think this might work. All right, so where was I? I was drawing, okay, and then my current minimum x was 1.5, and my current index was 0. Okay, it looks better now. All right, this looks better now. So yes, so I was saying we found the first one, we found it was smaller than any other one, and so we store the value that we have found, 1.5, and we store where we have found it, at position 0. Then what we do is we check the next one. And as we check the next one, is 2.4 greater than the minimum value that we have found before? So is this greater than 1.5? It is not. So if it's not, then it doesn't work. We skip it, right? So we don't want to care. So do we check the next one? Is 3.7 smaller than what we have found so far, 1.5? It is not. So we skip to the next one. Is 0.6 smaller than anything we have found before? Yes. So if that's the case, then what we do is we remove the 1.5, and now we store here at current minimum x, we store 0.5 as the minimum value that we have found. And we also store in the other variable where we have found it. So that was at position number 3. So we keep doing over and over this and over again. And if you look at the table, what would probably end up happening is by the end, while after checking all the 10 points, we will end up having that the current minimum value that we have found is minus 2.7, and that the index number where that happened was number 5. So if that's the case, then what we do now is, after we have finished the first round, what we do is we take this point here, we take 0.5, and then we move it to the new list. So this is going to be the new list, where it becomes object number 0 at coordinates 0.7. Okay? And then we remove this object from the list, therefore all these numbers rename to 5, 6, 7, and 8. And we have a list with one less element. All right? Let me redraw this in a way that looks a little better. Okay, so let me do that. So let me create a new layer, and in the new layer, I'm going to do black here, and then I'm going to say this element is going to be this element is going to be number 0. The coordinates are going to be minus 2.7. All right, and then I should remove this element from the list. So what I should do is I should delete. Oh, that's very. How can I change the size of the delete brush? Hard eraser. Okay, and then I need to choose the layer, so that's going to be this one. I need to choose this layer here. I'm also going to delete all of these elements, and I need to choose this one, delete this. Let me save this with a different number now, and I need to rewrite. Now. This is going to be number 5, 6, 7, and 8. Okay. Okay, I think that looks good. Okay, so I think this looks a little better. So that's my new list, the one on the right, that has the first element that we found with the smallest x. And now this is the remainder list, which is the same list that I had before, but I have removed the element that was in this position. Okay, oh, my finger. The element that was right there. Now there's a gap, and all these numbers here, 5, 6, 7, and 8, now these are the reordered indices that just have reordered automatically because of the fact that I have removed one element from there. Okay. Remember that the new element on the new list, the new point, becomes element number 0 just because it's the first one on the list. So that was the first pass that we did on the list, and then what we're going to do is we're going to keep doing passes and passes and passes until we empty the full list of points. But every time we start a new pass, we need to do a couple things. We need to make sure that we reset. These values, because if we start with minus 2.7 when we start with the next round, then no point is going to have an x property smaller than minus 2.7. That was the smallest one we found. So we need to reset these to some kind of very large value. Again, let's start, for example, with 1 million or something. And the current index, it's common practice to use, for example, -1, because -1 is a number that can never be an index number. So if we ended up writing some code, and after the loop, for some reason, the current index was still -1, we would know that something went wrong, that something just didn't work out. So that's why it's a good flag to keep track of whether if we have found something. So again, we would do the same thing again right now. So we would do is like we would start with the first point. The first point is 1.5 is less than 1 million. So we would do 1.5 and then we would store number 0 here. The next one 2.4, 2.3, not at all. We stay with 0. The next one we find is 0.6 and then index is number 3. And then the next one is minus 1.3 and index number 4, which if we keep going down the list is the last one that we find. So what we would do is now once we have ended iterating, we just take this point, we move it here, this becomes point number 1 and then with a coordinate of minus 1.3. And as we go into the next loop, we do the same thing again. We initialize this again to a very large number, 1 million and minus 1, and we keep this doing over and over again until we end up with a new list that has all the elements sorted one after the other, okay, by their x coordinate. So this is conceptually what we're going to do, and we're going to follow the same looping approach, the same like taking the same idea of like using a variable that keeps track of the last value that we found that matched the criteria for sorting that we're trying to use, and using another variable to keep track of where we found that point on the list. This is the core of the technique that we're going to use for these algorithms to sort. Now, whether if the criteria is going to be the x coordinate, the y coordinate, if it's smaller or greater than the last one we found, or if it's the distance between points, that will change depending on the algorithm. But the same iterative looping over and over and taking points and moving them from one list to the new one, that's going to be the core of what we're going to do for all the algorithms, okay? So now let's take a look at how that would be written in actual code terms. Let's go back to coding. Okay, was this clear? Technically, was this clear from a conceptual point of view? Okay. Are we going to need to use backward for loop for this algorithm too? That's a really good question, Arasto. He's asking a question due to what we were doing. For this case, we will not, because what's interesting about this algorithm is that we need to finish looping over the whole list before we actually remove it. So we are not going to be in the position, we're not going to be in the danger of like, while looping, removing an element and then having all the index number rearranged and then skipping further checks. That's not going to happen in this case because we always remove the element once we have finished for looping. The danger is when you remove elements while you are still looping. That's when problems can come up. But in this case, we don't have that problem. So we can just loop from the beginning to the end. And then once we're done, we take the index number, and that's the point that we move to the new list. But that's a really good question, Arasto. Thank you. So let's get going. So where were we? Yes, points, sorted points. Okay. And then here, all right. So that's going to be, actually it's going to be super easy to implement. So let's take, okay. Wonderful. So back on Grasshopper, I'm going to open my C# script component, and I'm going to access the main function, which is the one that takes all the points as a list, which by the way, I forgot. I need to right click here and make sure that I click list access. So instead of having one point at a time, when I click here, I actually do have as an input to the function, I have a list of .3D objects. Okay. Then what I'm going to do is going to be super easy. I'm going to create an empty list to store sorted points. So that's going to be a list of .3D elements. So new points, for example, or S points, sorted points. And this is going to be a new list that I'm going to initialize empty. And it's going to be of the type point3d because I'm working in Grasshopper that has a struct that is point3ds. But if you're working on any other environment, you can use any class that has XYZ properties or something like that. And then here, I'm also going to create the two variables that I'm going to use to keep track of the most of the criteria that I'm using. So, for example, I'm going to create variables to keep track of checks, and I'm going to say, for example, I'm going to use a number for minimum x, and I'm going to use another number for minimum index. Actually, I'm going to why not calling them just like we did? So current minimum x and current index. Let's just do just like we did on the diagram. Okay. Current index is not a double; it's an integer, and I'm going to initialize it to -1 as I did in the diagram, and then current minimum x. I could just initialize it to a ridiculously large number, but it's common practice to actually use some kind of system variable that can give us the largest number that can be stored, for example, on a double. So I believe in C#, the way you do that is double dot, and then you access here this property called max value. And if you're curious about what that value is, I can just print that to current minimum x to string. I can print that to the console, and if I run this, I can post a panel here. I can place a panel here, and that value in C# is like 1.7976 with 308 zeros afterwards. Okay, so this is an exponent. This is exponential notation. This means this number times 10 elevated to 308. So, or otherwise, this number, but instead of with the decimal point here, with 308 zeros afterwards. Okay, so if you are working on any other environment, maybe you have access to something like this. Otherwise, just write any very large number here that you think is going to be always bigger than any of the x locations that you can find on the points that you're bringing in. Okay, and then here, what we're going to do is we're going to write a for loop that is going to iterate over all the points. So there's two ways we can do this. We can just write a for loop. For example, int I equals 0, I is going to be less than s points dot count. So the amount of points, the amount of points in the list that is coming in. So this one, and I plus plus. And remember, we're doing this because every time we iterate, we're going to iterate one time per the amount of points that we have. Okay, so we're going to need to do this like if we have 10 points, so 10 times. If we have a million points, then a million times. And then what we do is, once we are here, then we're going to write another for loop. J equals 0. J is less than how many points are left here. J. And then with this one, this is the one that we use to go over each one of the points on the list. So remember, we need to make the process of checking all the points. We need to make it 10 times, and then every time we check the list, we also check it however many times there's items on that list. Okay, so actually that is not correct. Is that correct? That is not correct. Let me take a pause here. I think I'm confused. Wait. So what are so I think we're just going to do I mean, I think this should be fine. No, this should not be fine. This is not going to be fine. Okay, so yeah. So let me redo this. Okay, I think I was accelerating a little bit. I may have had actual caffeine in my coffee a little bit. So, but let me backtrack. So we're not going to do it exactly this way. So what we're going to do is, what we're going to say is, I want to keep checking the list of points that was given so long as there are any points on that list. So a better way to go about that is by using a while loop, where we can say while points.count is greater than 0, so as long as on my original list there are still points remaining, I'm going to keep doing these checks, okay? And then here inside, so as long as we have points, keep checking. And then here, this is where I'm going to declare my variables. So current maximum x is going to be equal to double dot max value, and int is going to be current index is going to be -1. And then here, now for each time I check, now that's where I want to have a for loop that goes from the first point to all the points on the list, finds which one is the minimum value, stores it, and then moves that point to the new list. So here I'm going to do for int I is less than 0, I is less than however many points I have on the list, so point count, and then I plus plus, and then here for each point what I'm going to do is if the element I, so each one of them, if the x coordinate of that point is less than the current minimum x that I need to change, if this is true, then this is the point that becomes the new minimum. So what I do is I can say current minimum x is going to be equal to the x coordinate of that point that I just found, and the current index is going to be equal to that index, the number in which I just found it. So if I do that, that's going to start working. But then before I exit, I need to remember to take one point from this list, the one that I found that was the smallest one, remove it from points and add it to the new list that where I'm keeping track of those sorted points. So this, I'm going to call this sorted. And because otherwise, if I don't remove those points, I may actually get trapped on an infinite loop. Because this, if I don't remove points, this is going to be always greater than 0, so it's never going to stop. When using while loops, it's usually a bit more dangerous because it's sometimes if you don't remember to write things correctly, you can get trapped on infinite loop, and then you have to the computer crashes, blah blah blah. It's not great. So what I can say is, let me add to the list of sorted, add whichever points at whichever point was the smallest one that I found. So the one that is going to be at index, current index, okay, and then from points, then remove the point that is at current index. So let me put some annotations here. Iterate over all remaining points and find the one with the smallest x coordinate. And now move that point to sorted list and remove it from original list. Let's see if this works. Is this going to work? Oh, well, there's no errors. but also there's no sorted points because I haven't really assigned that yet. So let me just write here the output sorted points is going to be equal to that list that I just created. And if I do this, I have a list of points, and let's check this out visually. Does this make sense? Oh, this looks like it could make sense. All right, so let's see if we can make that sense of that visually. So if I plug in here a list of vertices, this okay, and we can see more or less, if I go to the top, we can see that now the polyline is ordered somehow, and it feels like it's sweeping the points from left to right, okay? And if we do a front view, then we're probably going to get the same, a very similar visual. So, so that was it. So we have now taken all those points and we have sorted them out by X property. All right. Okay. How was this? Was it good? All right. So, what are we doing now? So I can explain how to sort by X coordinate, by Y coordinate, or by Z coordinate. And maybe what we could do is we could write something where we take an input here as a string. So the letter X, the letter Y, the letter Z, for example, and then use that to discriminate how we're going to sort. Yeah, let's do that. That sounds fun. Okay. I think something that could be fun now would be to write the same, but give the user, whoever is calling this function, give the user the possibility of choosing whether if the points are going to be sorted by X, by Y, or by Z coordinate, right? And instead of just hard coding that in the function, then maybe what we can do is like we can pass in a parameter, so the letter X, the letter Y, or the letter Z, and then use that as something that can inform how the algorithm sorts over these points. So what I'm going to do here is I'm going to add a new input, and I'm going to call this coordinate. And this is going to be of the type, for example, we could use numbers. So we could use 0 for X, 1 for Y, and Z for 2, or 2 for Z. But I think it's actually easier to just do a string so that people can type. For example, the letter, so people can type, for example, the letter Z, and then that's what becomes the input here. Okay. And then let's go back into the code, and then what we're going to do is we're going to inside of the code, we're going to write some small code to be able to discriminate between us which is the coordinate that we're going to take a look at here in this line of code. Okay, how am I going to do that? Does a point 3D object, does it have like, I wonder if it has like an accessor is valid maximum coordinates. I wonder if it has something where I can do like, yes, nice. So I can do P and give it an index number. So for example, give it an index number, and if it's 0, then it's the X coordinate. If it's 1, it's the Y coordinate. But I think this is a very Rhino common specific. If people are writing this somewhere else, then maybe they don't have that possibility. So So I'm going to write it both ways. I'm going to write it if you don't have that possibility, or if you want to just do it more programmatically, then use then just if you want to write it more programmatically, then use the Rhino common accessor. Yeah, I think we're going to do that. Okay. The first thing we're going to do is we're going to check the input coordinate, and we're going to check whether if it's X, Y, or Z. And then we're going to keep track of that with an integer number inside of our code. We're going to do that just because comparing strings is a little trickier usually than comparing numbers. And computers have a much easier time comparing integer numbers, especially integer numbers. They're very easy to compare and very fast. So what we're going to do is we're going to just write some code that looks at the string, makes some comparisons and some safety checks. And if everything goes well, then we will use that number to then discriminate in the algorithm. So for example, something that I can say is check the input coordinate. So I'm going to create an integer value here that I'm going to name coordinate integer. And again, I'm going to initialize it to -1 because it's usually, because if it stays at -1 after the checks, then I can know that something went wrong. So what I can do is now I want to compare the coordinate, and I want to say if coordinate, and let me check how to write lower cases in C#. Okay, so C# string to lowercase. Yeah, so it's like this. Returns a copy of the string converted to lowercase, and then C# string equality. I always forget if C# can compare strings correctly or if it doesn't. So for example, let's make a small test here. So I put C, so print to the console, print is coordinate equals Z, and this should be true. Is this true? Can it be applied to open? It's a character. Okay. Yes. So I need to do this, and then I need to wrap this. And then I need to wrap this like this. It's true. It's true. I think so. We can compare them directly. All right. So that's going to make things a bit easier. Yes, so the method to take a coordinate and turn it into lowercase is going to be to lower. And remember, we want to do this because we want to give the user the possibility of having uppercase or lowercase inputs and not have an error. So whatever they give us, we just turn it to lowercase and we say, is this equal to the string x? If so, then coordinate integer is going to be equal to 0. Otherwise, if this is equal to y, then coordinate integer is going to be equal to 1. And then if this equals c, then this should be equal to 2. All right? But there is the possibility that the user just inputs something that is wrong. So we want to also make sure that we check that, because otherwise we could have problems in our code. So what we can do is, if the user did input something that was not an uppercase or a lowercase XYZ, then this number at this point in the program is still -1. So what I can do is I can say if coordinate integer is still -1, then something went wrong. So I can say component add runtime message, and then Grasshopper runtime message level dot error wrong coordinate input type. Okay, let's see this in action. So let me run this code. Right now it's fine. It doesn't complain, but if I type something that it shouldn't be, it tells me wrong coordinate input type. So I'm going to go back to Z, for example. Okay. All right. And now that we're here, now what we can do is we can just write something in the code, something like, for example, this could be now, I'm going to rename this to current minimum, because now it's not an X or a Y, and we want to write code that is a little cleaner. So I'm going to rename that current minimum here. And then what I'm going to do is here, I'm going to write a series of if-elses. So if coordinate integer is 0, then what I want to do is I want to check for the X property, just like we have right now. I want to check for the X property. Okay. Now, otherwise, if the coordinate is 1, that I want to choose for the Y coordinate here. Otherwise, what did I do? Otherwise, if coordinate integer is 2, then what I want to check here is for coordinate Z. Okay? Is that going to work? Let me check. So I'm going to run this code, and right now, something got messy, but if I do front view, you can see that things are now sorted by Z coordinate, and if I replace this and I do Y coordinate, you can see that the top view makes things order from X lower X, so from Y in this direction, and I capital X also makes things sorted in the X direction. So now we have an input, we have a component that can order points in any of the two directions. All right, how cool is that? Okay, and now I want to do a small thing where I modify this, and I do it a bit more Rhino common specific. Okay, so let me save this before I forget. Before I go on, I also want to rewrite this in a way that is a bit more specific to the Grasshopper environment, because it just so happens that when we are here, the fact that every time we have to check if else, coordinate int, there's a lot of if else checking. So if this was 1,000,000 points, it could be a little expensive. So in order to simplify this a little bit more, we can take advantage of one of the properties of Rhino Common point3D objects, and it is the fact that in order to access the X, Y, and Z property of a point, we can either do this by writing .x, .y, or .z, or we can also access the so we can also access with an item access. So what that means is that, for example, if I write a random point, so for example, point 3D P is going to be a new point 3D with whichever dimensions, it doesn't matter. If I do P, the point, and I open square brackets, you can see how I can use an integer 0, 1, or 2 to retrieve the X coordinate, the Y coordinate, or the Z coordinate. So it gives me an accessor kind of ability to get each one of the three coordinates by, instead of writing .x, .y, .z, just opening and closing square brackets and adding the number of the property that I want to access. 0 for x, 1 for y, and 2 for z. And because we just calculated that number here, then that can actually make our code a bit cleaner. So what I can do here is I can say I'm going to clear all this up, okay? And I'm going to now say, instead of .z, what I'm going to use is I'm going to open a square bracket. I'm going to say chord int, because this is a number that I calculated before, and I'm going to replace that here as well. If I run this code, things work exactly the same, but now if I replace this with a y value, then this adapts correspondingly, and if I do z, then it also changes. And the code is a little bit more optimized because we don't have to do so many if and else checkers. We just did this one check here for sanity with the input, and now that's embedded in the coordinate that we actually have here. So, but we could only do that because that's a property that point3D objects in Rhino Common have. If you don't have the possibility on whichever environment you're working, then you may want to modify the point class that you're using here, or just stick to the version that I showed before. All right? Okay, so I think we are ready to leave this component now and create a new component with a similar technique where instead of choosing X, Y, Z, what we do is we sort them by proximity, by which points are closer to each other. Let's try that out. Okay, so how are we going to do that? Oops. So I'm going to move all of this here, and I'm going to call this sort points by coordinate, and I'm going to boom. And this is going to be my C# script. And I'm going to copy and paste this. I'm going to remove this input. I'm actually going to delete the input altogether. And then I'm going to rename these sort points by distance. And I'm going to remove. I'm going to. And I'm going to. Yeah. And I'm going to turn this off here. I'm going to keep this. How are we doing, everyone? How are you feeling? Was this difficult, hard, easy? You guys can take more. This was a good pace. You let me know, okay? What else do I have? So, sort points by distance. Okay. So we're basically going to write the same thing. It's just that we're going to start calculating distances between points. Is there any, are we going to find any problems here? What problems may we find? Actually, let me input here, because I'm going to do like the minimum and the maximum. That's going to be cool. Is this going to be a Boolean or a number? This is going to be a Boolean, probably. Thank you, Benson. It's going to be a minimum. And I'm going to turn this into a Boolean. And yes, it was a Boolean. Okay. Okay. Actually, let me add this later, because it can be a little confusing. Yes. So let me add that later as an option that we can change the code with. Yeah, that's better than just throwing everything right there. Okay. Okay, I have resorted everything a little bit. So I took the component that we had before and I wrote here the name sort points by coordinates, because like maybe if I'm writing a Grasshopper plugin, like this could be like my new my new component that I'm working on. And I copy pasted this and I made a very similar one that I'm going to call sort points by distance. And then this takes in the list of points. It spits out a sorted list of points. And right now it just has the placeholders for a new empty list that is the sorted one, and the output that will be whenever we fill this in with all the points. Okay, so we're going to do a very similar operation where what we're going to say is while all the points that we took, while this list is greater than 0, the amount of points that there are there, keep iterating. Okay, but I'm going to cancel this out for the time being, because if I do that, if I were to run this code, I would hit an infinite loop. But we're going to break this down a little bit before. Before we start doing this, we need to take the first point that we're going to start checking. So what is that going to be? We need to say we need to take the first point. Let me let me all right, sorry. Let me go back to the whiteboard. Okay, I need to explain something. Yes, I was not going to. I needed to explain something. I knew I was overdoing this. So can I save this and then can I go back a lot here? How much can I go back? I like this. Yeah. And let me delete this up here. And let me add some more text. And I'm going to turn this one off. How can I? Oh, here. Okay, and I'm going to turn this off. And okay, the one thing that I need to explain for this algorithm is a slight change that we're going to do. And it is the fact that before, when we were checking the list for x coordinates, something that happened was that all points are always going to have the exact same x coordinates, because points are not going to change. So the property that we're using to compare, we can call it static, because no matter what we're doing or where we are in the program, the x coordinate never changes. So it's a bit easier to do. We need to keep track of less things. However, if what we intend to do is we take one point and then calculate all the distances to all the points around it, find which one is the minimum, and then use that, take that point and make it the next one that we check, then what happens is that all the distances for the next iteration of checks are different, because they're not the distances from the previous point. They are the distances from the new point that we just picked up. So we need to recalculate all those distances, and therefore the list of things that changes, the list of those numbers, is going to change with every iteration of the checks. So something that we would need to add here to the current index would be like a new variable called, for example, current point or last point or something like that, where every time we check the distance from the current point to all the other points. We take the one that is the smallest, and then we store that point. This is going to be a slight difference, so keep in mind. And I think we're actually going to use that all together instead of using current index, because since we're going to be retrieving the point, we don't really need the index value anymore. Okay, so let me show you how that works. So here, what we're going to do is we're going to create a variable called current distance, and that's going to be also, again, is going to be like a number that is going to be ridiculously large. So double dot max value. And we're going to create a point 3D object that is going to be the last point that we check. And right now, we need to initialize this to some value. So what we're going to do is, we're going to say, for example, from the points list, I'm going to take whichever is the first point. We could come up with a rule with like a point that is like the last one on the list, or the one that's more in the center, or whatever. That's fine. It doesn't really matter. And we need to remember that we should take that point and we should put it already in the sorted list, which is because it's the first one that we're going to be using. So sorted, we should add from points, we should add the first element there. And we should also, from points, remove that point. Okay? That's it. So here, what we're going to do is, here, pick first point and move it to sorted. All right? And then keep track of the last smallest distance. And I think we are now on a good position now to start going over all the points in the list that we got, and then create a for loop where we iterate over I is less than 0. Oh, my neighbors are screaming. I is I less than 0. I is equal to 0. I is less than however many points are on the count list, and then I plus plus. And then here we can say, let's calculate the distance from our current point, from the last point that we found to the current point that we're going to be checking against. Okay? And for that, what I'm going to do is I'm going to use some code that I already wrote for the geometry gem number 4, where we looked at distance between points, and the link of which should be popping up somewhere here, somewhere. So let me go and get that code. So where is that code? Yeah. My neighbor's kid is playing in the backyard, but if I close the window, I'm gonna pass out. So I think that's gonna be the background noise. Can you hear him? Okay. Distance between points. Okay. And distance, I'm going to take. Okay. And then I'm going to shut this down. I don't want to modify it. Yeah, you can hear the kid, right? Okay. Whatever. Okay. All right. Oh God. Okay. I have a little bit of OCD, if you guys can tell. I like things properly aligned and in place. And here it is. So these are the two functions that I wrote on the geometry gem number 4, where we were discussing how to calculate the distance between 2 points. And this is a function that we use for regular distance, but remember, in that gem and in gem number 5, when we were cleaning duplicate points, I also discussed how when you are using distance to compare things, where you're not interested in the actual distance, but you're interested in comparing that distance to other distances, it's actually much faster to use the distance squared, because if you're comparing the straight distance between 2 points, then that comparison is going to be the same as if you compare those square distances. And with the square distance, you save a little bit of computation. So if you want to learn more about that, go to those videos and learn why this is important. And I'm going to use the square distance to compare those points. So so here I'm going to say, I'm going to compute the square distance between the distance square between the previous point that I found, so last point, and the current point that I want to check against, so one after the other in the list. So that's going to be points.i. And if d2 is smaller than the last distance that we found was the smallest, then current distance should be equal to this distance that I just calculated, and oh, I need to add another variable here, and yes, and the index number. So that's going to be, what is it going to be? It's going to be current index is going to be -1, and then current index is going to be equal to where we are right now, I. Okay? And then once I finish this for loop and I have checked all those points, what I need to do is I need to say, let me take the point that I found. So let me point the point that I found, and let's say the last point that I found is now going to be equal to, from the points list, is going to be equal to current index. And now what? And now I need to take, that point. So let me write this. Let's point 3D, the chosen one is going to be equal to that point from the list of points, the one with the current index that I found that had the smallest distance. All right. So when I do that, now I can say I'm making this a little confusing, sorry. For the sorted list, let me add that point, the chosen one. From the points list, let me remove the point that is at the position that I found, at the index that I found was the one that had the smallest distance. And also remember that for the next iteration, I need to make sure that last point, the one that I'm always checking distances again, is equal to this one, the last one that I found, the chosen one. And also, I need to remember to reset current distance to be equal to a really large number and current index to be equal to -1. This is actually not necessary, but it's good practice to remember that. So let me just write some comments here, or I'll do the comments offline. So let's see if this works. If I run this, this kind of works. Oh, and what do we have here? So we have so let's see what we have here. Let me do this. Okay, so you can see that now we have a much more interesting distribution than when we had just like the pure random points where like the polyline was going over and over again, through all the points. Now, because they are aligned by proximity, you can see that interesting things happen, such as, for example, these points here, like being kind of aligned, and then it gets into this this one here, and it's very difficult to trace, but you can see how like the polyline gets here, down here, but then there's also like this point. This is a really, really interesting distribution. And something that happens also, can you see this very long straight line here? What's happening is that probably this is the very last point, and as the algorithm was sorting through these points, there were very few points left. So at some point when the algorithm was here, 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 and it had this point, probably from the whole cloud, the only points that were left were these three here. So that's why it had to do this long jump here. A similar situation may have happened here, where there was a long jump between these 2 points, right? Because I'm assuming those are probably the ones that are by the end of the check. Um, so, and there's another one here, another long jump here. But I think this distribution of points is actually it's making things very, very interesting. So yep, that is sorting points by proximity when the distance is the smallest distance between them. Something that we could also try right now is to, instead of sorting the points by proximity in terms of the shortest distance, we could actually force this to sort the points by the maximum distance, so the ones that are farthest apart. And just like it right now, this algorithm creates this very nice order yarn of polyline where elements are very close to each other. If we choose the ones that are farthest away, we could probably create some kind of polyline where the polyline is constantly zigzagging over the most extreme points and then starts slowly creating concentric relations into itself. So that could create some interesting geometry. Let's try it out and see if there's anything cool we can find there. Benson, are you accusing me of being a Python person? Not cool. I may have to mute you. Control K and D. Is that true? Is that really true? Let me move this. Control K D. Oh my God, Hari Prasad! You just blew my mind. I had no idea. Oh my God, how much time in my life have I wasted aligning things in Grasshopper? Oh, you see, this is why I like doing these things live too. I also learn things. All right, that's awesome. Okay, thanks a lot, Hari Prasad. Where are we? Yes, we're going to add some kind of, yes, so input to change the way this behaves. So, okay, let's do that. I'm going to save this file. And let me add some comments. Yeah. Iterate as many times while there are still points in the list. Keep iterating. Distance to compare. Cheaper operation. All right. Check against last best value. All right. Oh my God, it totally is a game changer. It's huge. It's huge. Once checked, move the point to sorted list and remove from original list. Remove point from source list and move to sorted list. Prepare for next iteration. Okay. Hari Prasad, how did you learn that? Where did you find? Is there somewhere that you can check the key bindings for this? Is there like a document or like a cheat sheet or something where you can read what's available? Can we learn more? All right. Okay, so yes. And okay. Okay, so what we're going to do is I'm going to add a new input here that I'm going to call, for example, by minimum distance. And I'm going to make sure that this input is a kind of Boolean value, so that if this is true, then we check by minimum distance, but if it's false, then we check by maximum distance. And then it's going to be as easy as just going into the code here and then saying, this is where I'm checking if the distance is less than the previous one. So this is what I need to say. Let me check if we are checking by minimum, if this is true, and if this is true, then D2 should be less than the current distance. And if that's true, then we do this. But we're going to add here a new line, and we're going to do parentheses here. And because we're going to check by this, or the other possibility is that we check, well, if by minimum is false and D2 is greater than current distance, then store that current distance here and do current index here as well. Now, one thing that I need to remember is, let me run this code. Okay, I'm going to run this code, and I'm going to save in case it crashes, because if I do false now, things are not going to work, and you see that something is going wrong here, and it's not going to work because remember that the first initial value that we used, because we were checking for points that had like smaller distance, we started with a ridiculously large number. But if we were to check by points that have like a larger distance, then we want to start with a value that is ridiculously small. So what we can do here is we can say, we can write by minimum equals true, and if that is the case, then we should use double dot max value. Otherwise, we should do double dot minimum value. All right. This thing that I have written here, in case you're not familiar, is called a ternary operator, and it's basically a very simple conditional statement. This is just this is the same thing as saying current distance and then writing if by minimum equals true, then current distance equals double max value. Otherwise, this equals minimum value. So this one line of code is exactly the same as these 6 lines of code that I have written here. It's just written in a more concise way. If this is true, choose the first parameter. If this is false, choose the last parameter. And actually, we can write this even more concisely if we just say, is this true? Question mark, then choose this value. But if this is false, then choose this other value here. And that we can also move here, because we need to reset that right there. So if I run this code now, and if I turn this to false, we get this really strange geometry, which is basically like a porcupine or like a sea urchin, right? And because all points are sorted by the farthest away they are, they keep just zigzagging. They keep zigzagging back and forth over the space in which they are contained, which I think is kind of cool too. So sorting by distance doesn't have to be by the minimum, it can be by the maximum, and depending on what kind of sorting algorithm, you get very different results when it comes to, for example, joining them with a polyline. All right. So I think that's about it for this gem. Something that I would like to remind you is that we haven't really, when it comes to sorting, sorting is one of the fundamental principles of how people understand and how people write better algorithms in computer science and in programming. Because sorting is an operation that, because you have to keep checking every element against all the others, it tends to be an operation that can be expensive. So there are multiple algorithms and multiple ways of doing sorting out there that try to address the problem of optimization and writing fast algorithms that can compare things against each other. We haven't gotten into that topic here yet because it's a huge topic to address. I was just more interested in getting something quick that works and that is reasonably performative. It's reasonably performative in our case because we were always checking ones against the other and removing one. So instead of checking everything against everything every time, we were checking at increasingly decreasing sizes, which creates a triangular distribution of checks that makes the computational time basically half the time of all the elements that we have multiplied by all the elements that we have. So instead of, if we have 1,000 points, instead of making 1 million checks, we were roughly doing 500,000 of those checks. But if you're interested in better ways of sorting things, I recommend you go online and there's like a lot of tutorials and algorithms that you can check. I was more interested in the geometrical implications of what criteria we choose here to sort these points, and how visually it's actually very different to choose, for example, to sort them by proximity, so very close distance, to sort them by proximity, as in very far, very fast distance, and what kind of designs you could do with this, and what implications this could have for 3D printing or for drawing geometry or for creating mazes. That's absolutely up to you. All right. So thank you very much for staying here, and I hope you join us for the next gems. Bye. Oh, and if you like this, remember to subscribe and to like. That's very cool. Thank you. Bye. All right. Okay, I need to record the intro. All right. So, introduction. Definitely coffee today. All right, I'm going to record the introduction, and I'm going to do like 5 minutes of Q&A if you want to stick around. So let me just do that real quick. Hi, and welcome to this new geometry gem where we're going to discuss like a bunch of different sorting algorithms that we're going to use to sort a point cloud by different criteria. So for example, we have this point cloud that is absolutely random, and if we join them with a polyline, you can see that the polyline is just zigzagging all around the place with no order, just because the points don't really have an order between them. But if I choose to sort them by X property, for example, you can see that now the polyline is sorted in the X direction, or I can choose, for example, to change this to sort them in the Y direction. So now you can see that the accordion kind of polyline is going in that direction, or if we could also choose to sort them by Z height, and then all the points are going from the minimum to the maximum Z height. But at the same time, we can sort them by other criteria that is not just Euclidean location, but can be, for example, by proximity. We can choose to join all the points one by one, the ones that are closer to each other. So for example, here, what you can see is that all the polyline that we create over all these points sorted by proximity, it creates now like a polyline where points are joined by the ones that are much closer to each other. But we can also choose to sort by the ones that are farthest apart. And if we do that, it basically creates this sort of like sea urchin kind of geometry, which I find really interesting. The algorithms that we're going to discuss are very simple. We're not going to get into hardcore sorting algorithms in computer science. I'm much more interested in the geometry results that we generate. And we're going to implement this in C# using Rhino and Grasshopper, which is a visual programming environment that allows scripting in C#. We're almost going to use no native Grasshopper properties, so nothing from Rhino Common. So if you are working on any other C# environment, or if you're working on with any other programming language, you will have a very easy time rewriting these algorithms and adapting them to whichever system you're working on. All right. So let's get done. Let's get busy with this. All right. Okay. Thank you, Andres. That was great. I really enjoyed it too, actually. That was very nice. And it was like a simple thing, but you see, you can start doing like really cool stuff with this. So, okay, so I think this is going to be it for today. I just saved this. And I'm going to switch to Q&A and conversations. So if you guys, let me go grab some water. If you guys have any questions or anything you want to talk about, please post it in the chat window. Otherwise, we can start the weekend, I guess. I'll be right back. Just give me, just gonna get some water. Okay, I'm back. Arasto. Okay. Oh, where's the microphone? Thank you for the class. Oh, Harry, I'm not sure if I've seen you around. Okay, Benson. Today was fun. Definitely a coffee day. Yeah, I think I had. I have to confess, I added like a tiny bit of real coffee in the coffee. I don't know what I'm doing with my life. I'm an addict. Okay, and then here. All right. Could we have a live session? Sorry, I'm skipping. Thanks to you guys for sticking around. Could we have a live session that would think about the implication of scripting in actual architectural design project rather than abstract geometrical implications? What does that? Most of the things that I could find was about environmental designs or exhibitions. What do you mean by that? So can you elaborate a bit more? So the implications of scripting in actual architectural design projects. The idea is that scripting or writing code in general is about breaking down thought processes into rules and into logical processes. I'm going to turn the AC on now because I'm not recording a good video anymore. So because we're not. So the idea of I think what's interesting about computation in architecture is that it forces you to streamline your thinking and it forces you to break down the rules that you're using to make decisions when you are designing. And that's something that is a bit counterintuitive because in design and in art, there's this conception of like the intuition. So the idea that, oh, I'm going to create something, I have this intuition that it should be like this, but I'm not entirely sure what decision or where that intuition came from or what made me make that decision, right? So the idea of like inspiration and like stuff that comes from nobody knows where, it's an interesting one, and it's often used when in creativity. What I like about computation is that it forces you to think the other way around. How can we still be creative while thinking logical processes and breaking down our thought process? That's one thing. And the other thing is like, once you learn these techniques, how can you use the techniques that you have learned to express that creativity. So the other way around, going bottom up. I know how to use the tool now. Is the tool giving me ideas of new things that I could do that I had not thought about before? Um, so I find that process also very interesting, and it's one that I like very much to discover while I am learning new frameworks, learning new techniques, and thinking like, oh, how could I apply this to like design a facade, or designing like a print object, or creating a 3D print, or designing a sculpture, you know, those kind of ideas. Um, so what about Delaunay edges components? It was a kind of sorting algorithm to find the closest pair of three vertices. Could be in the list of geometry jam for C code. Delaunay is it's similar to what we've done. It's just much more complex because it involves a bunch of other algorithms. So, for example, finding circumscribed circles between 3 points, so something that I will need to make a gem on, and then writing algorithm. It's a bit more involved. So for that one, it's totally on the list, Andres, and it will happen at some point. But that one I need to prepare ahead because it's a bit more involved, and there are that I know of at least two big popular algorithms that allow you to do that with some optimization so that the process is not very expensive. And also, there are some implications in the process when you go from 2D to 3D. So it's not like calculating the distance between 2 points, which is exactly the same in 2D or 3D. For Delaunay, there are some slight differences that you need that make it a bit more complex. So that one I'm going to need to prepare for, and so it's not going to happen anytime soon. Sorry. And Voronoi is the one that comes after Delaunay, and that's also super interesting. I hope to make a piece about that one at some point, but not this month. Maybe not this summer, actually, because it's we're going to need to build a lot of stuff before we get to that point. Flor, I often find it useful to reverse engineer examples that inspire me. Huh? Yep, that is true. Like what examples? What have you found inspiring lately that you would like to reverse engineer? Maybe this is something that we could do here, you know? All right. Okay. So I think with this, we are probably good. I have a lot of stuff to do this weekend, so I think I'd better get ready. Okay, well, it was a pleasure. Thank you very much, everyone. Thank you for sticking around. Um, and I'll see you maybe next week if you signed up for the Digital Futures workshop, or if you or if you I posted it on Discord, if I post the link and you join. Otherwise, I'll see you on the regular live stream in 2 weeks, and probably by then. No, sorry, in 2 weeks. Is that 4th of July already? I'm taking 4th of July off. So I may not see you after that. All right. Okay. Well, thank you very much, everyone. Have a good evening, night, weekend, day, whatever you are, and see you at some point soon. Okay, just stay tuned and subscribe if you want to know when I live stream again. Just subscribe or follow me on Instagram. Follow Parametric Cab on Instagram. And you can stay up to date when are we streaming and everything. And join the Discord. I always post in the Discord what's going on this week. Okay. Thank you very much. Have a good one.